So over the course of the next half hour or so, we'll be looking at cost optimization and management as it relates to AWS technology, together with our partner Densify. And whether you already run your systems in the cloud or you're looking to migrate them to the cloud, you want to deliver business value at the lowest price point. However, predicting and managing costs for large deployments can sometimes be overwhelming, and because the cloud's elastic and easy to provision and virtually limitless, it's easy for your costs to spiral out of control. So understanding billing from the cloud vendors and implementing cost controls has actually proved somewhat difficult for many people. So through this talk, we'll be taking a step back and looking at these challenges in more detail, and together with Densify, we'll look at controlling and optimizing costs through technology. You may have seen this cloud adoption curve before, and this is to show you really how people generally move through into a cloud journey. And typically what you'll do is you'll start thinking about the cloud and looking at it by running a proof of concept. And from there, you'll generally start to move test and development workloads to the cloud. You may start by using the cloud as an extension of your existing infrastructure, for example, by using AWS as your disaster recovery location. Or you might extend your on-premise storage to the cloud. These are all excellent uses of the cloud and a great way to start. But because it's so easy to start small in the cloud, simply using a credit card, it's also super easy for a shadow IT bubble to form as different groups in the organization start using the cloud in an uncontrolled way. As you start migrating production workloads to the cloud, and then enhancing those workloads and adding brand new applications, you may find your costs are escalating unexpectedly, unless you put in place good governance and financial control. A common cause for unpredicted expenditure is that cost governance for on-premise systems is very different. In the on-premise model, you pay for the infrastructure upfront and are then constrained by the infrastructure. The cloud, on the other hand, is utility-based computing, so you consume as much as you need and then pay after you use the service. The architecture team typically work within the constraints of what's available in the data center on-premise, but on the cloud, there are a few limits, so we see architectural decisions unintentionally leading to spiraling costs. Good governance and financial controls which meet your requirements need to be implemented, and AWS acknowledges this through its well-architected framework. Cloud computing has opened up the technology space to a whole new world of thinking where the constraints we used to have around infrastructure in a traditional environment no longer exist. And the cloud also makes it easier to clearly identify the usage and costs of systems, which then allows transparent attribution of those IT costs to revenue streams and individual business owners. And this helps measure return on investment and gives system owners an opportunity to optimize their resources and reduce costs. But you have to put these systems in place first. We've covered the well-architected framework in detail in previous episode, and if you'd like to know more about that, then please follow the link and you'll be able to see a recording of that. At HeleCloud, when we consider cost control and optimization, we have three themes in mind: technology, financial, and governance. I'll be dealing with financial and governance later, but first let's turn to how technology can help and at what stages it can help. Densify provides excellent technology that can be used throughout the cloud adoption curve, from the migration planning phases to the continuous optimization of large workloads. So without further ado, let me hand over to Roger from Densify to take you through what it can do for you.
So hopefully people can see my screen okay. And what I will do is I will cover off how Densify and HeleCloud address the challenges that you're identifying there, Carlos, through our enterprise-grade hybrid resource optimization and control, which is a bit of a mouthful, but at its basic core, what we're doing is making sure that we deliver the most efficient use of a customer's IT infrastructure, so have the correct type and amount of resources at the best price. So the approach we're taking here at Densify is basically to make sure we're reducing costs through the selection of the exact infrastructure resources, and that is the main driver. That's the key element to it, to make sure you're selecting and running on the right stuff in the first place. Then it's a case of looking at improving your purchasing strategies around reserved instances, savings plans, etc. And then ultimately getting into that state where you're able to deliver automated resource optimization. So I'll cover these topics in my slide set going forward. Before I do that, just want to level set to say that when we're working with customers, enterprises, what we're finding is that enterprises are hybrid and they will be in this state well into the future. So they will have their virtual infrastructure, their VMware environments. They will be using public cloud and multiple varieties of public cloud, and they will already have adopted containers or be looking to move into the container world. We understand that customers are also using different tools for their management stacks as they head towards that infrastructure as code. So it's a complex environment. And of course, OpEx is becoming a bigger concern. As Carlos was saying, the financial element is a big driver. And we're seeing this more and more across our customers, that the cost focus is a big driver for our customers. But let's drop down into a little bit more detail about how Densify works. So the core of Densify is a multi-dimensional resource and cost optimization engine. So this is the brains to our service. And into that optimization engine, we're feeding raw utilization data. And from that, Densify is generating application demand patterns. So we understand the peaks, we understand the minimums, we understand sustained activity, we understand the averages across a number of different resource metrics: memory, CPU, disk I/O, network I/O, etc. So we understand the demand requirements of your applications. And we're also feeding in information related to the infrastructure characteristics. So we understand the supply. So we understand the different technical capabilities, the cost of your different options and solutions across your different cloud providers. For AWS, we understand the difference in horsepower between going from one generation to another. So we understand supply. Because we understand both of those, we're able to fit, we're able to match your supply perfectly to your demand. We're also ingesting your tags, so the metadata. So Carlos will talk about how important this is in his next conversation with you. But this allows us to slice and dice your data, allows us to better understand the personalities of those workloads. And of course, all of this is driven by a deep policy framework. So this allows us to define policy settings for different groups of servers to drive the analytics. So your critical production systems will have a different policy to your DevOps systems. So Densify is ingesting all of this information and passing it through our optimization engine to derive optimization directives that are precise and actionable. And these come out across a number of different categories. So resource allocation. So this is very important. So this is point number one, making sure you're running on the right stuff in the first place. We identify systems that are optimal, so you have the right allocations. We're identifying systems that do not have enough resources, so they're at risk. We make recommendations for adding in extra resources. We're also identifying, and typically in public cloud, systems that are oversized. So this is where we can safely reclaim resources based upon those policy considerations that I mentioned before. We're also taking account of the workload personality. So if it's CPU intense, we're making sure you're going for a CPU optimized instance family type. So we're able to do that cross family type recommendation. Workload placement relates mainly to the VMware world, where we can place those workloads across your clusters. So I'll skip over that one for the moment. Hosting changes. So this is where helping you to migrate. So as you're migrating from your on-prem environment, so if you've got a VMware environment and you want to know what the workload looks like running in AWS, or you've got GCP workloads and you're deciding that you may wish to consolidate into AWS, what does that GCP workload look like in AWS? We're able to provide that as part of our transformation capabilities. And of course, we can help with purchase optimization around your savings plans, your RIs. We can help deliver recommendations in those areas as well. So these optimization directives are passed back into our customer teams, typically through reports or dashboards, or through integration with your ITSM tool, ServiceNow, Jira, BMC Remedy. And this allows change requests to be raised. Or we can, in fact, integrate with tools such as Microsoft Teams or Slack to make sure the right information is being delivered to the right people at the right time. This is all about getting the information out there so people can understand what the recommendations are, approve those, and action can be taken. And as mentioned before, we're seeing customers with a variety of different tool sets that they're using as part of the infrastructure as code. And what we're working with our customers to do is to integrate with their existing processes and tools to make sure they're able to take advantage of automated optimization. So taking this to another level, just to again give people an understanding that being able to select the right resources for your workloads is critical. I just want to drop down to a little bit more detail. So what we're doing is we're taking that raw utilization data and converting that into hourly usage patterns. We're applying machine learning to that to determine, based upon normalizing the workloads, if the resources that have been allocated are indeed the best fit. And if they're not, then to give you a very precise recommendation of what it should be. And in this case here, we've understood using this machine learning what the workload behaviors typically are based upon predictive analytics. We're looking at the normalized catalog, so the supply options. We're taking account of the policy constraints that have been set for this particular group of systems. And then we're able to determine if you are optimal or if indeed there is a better fit. And in this case here, we're making a recommendation to change from an M4 large, so general purpose, large, to a T3, so burstable, medium, because there's a better fit for the workload personality, as well as it's a more cost-effective instance family type to change to. So it's taking that detailed analysis, applying machine learning, and then determining the best fit for that particular workload. Very important to understand that we are driving cost savings, but what we are looking at is to ensure that we're balancing the needs of the engineering application owners who are looking at performance and stability with the needs of IT finance. So it's not driving all our recommendations purely based on what is the cheapest. What we're primarily aiming for is making sure the environment is stable. The performance of the applications is key, and that the environment is stable. That's the only way that you'll get app owners to agree to changes, if they believe the answers are going to make sure that the environment is stable and their applications are performing. So across a number of different resources within AWS, so whether it be EC2 or RDS systems, scale groups, what we're doing here is balancing. We're looking at those systems that are at risk, making perhaps those upsize recommendations to improve performance. But then once we realize that, okay, performance is fine, we then start to look at other possible recommendations. So for scale groups, potentially we may be making recommendations for the nodes within that group to be downsized, modernized to go to a new generation, or indeed looking at the scaling settings, so the minimum and maximum within that scale group optimization. But the intention is to make sure that all teams here are confident in the answers so that people can approve them and take action. Transform to cloud. So this is that element of Carlos's slide saying that as customers move from their one environment to another, it's very important to be able to analyze your existing workloads. And we've got this capability transform to cloud, which allows us to compare costs between cloud providers and determine the exact instance types. So what that means is if you've got workloads in your VMware environment and you're looking to migrate to AWS, we can do that analysis to tell you exactly, based upon the analysis of the workload, what instances and sizes should be stood up in the cloud. And then we can give you the cost of standing up those resources in the cloud, as well as running fit for purpose rules, which allows you to determine if you should be running, if you're allowed to run those workloads in a particular area. You may have systems from a particular department that you've designated cannot be run outside of a certain geographic area, and therefore you can use the fit for purpose rules to say, am I allowed to run those workloads in that particular hosting location? Another key element here is also being able to give you that comparison in terms of cost if you were to migrate, lift and shift, or if you were to optimize first or optimize as part of doing it. And we can give you that cost comparison between it as well. So once we've tackled the optimization resources here, running on the right stuff, what we're able to do, and in parallel with customers, we're working with them with regards to their RIs and savings plan strategies. So what we're doing is making sure that the RIs that you've already bought are optimized, so we can give very detailed recommendations in terms of exchanging existing RI sets. And as part of that, we're minimizing the true up costs to make that as cost effective as possible. We're also working with customers depending upon their overall strategy. If they are going to remain on RIs, or indeed if they're trying to manage away from RIs, moving into savings plans. So while savings plans are simpler to purchase and manage, not all customers are definitely dipping into just savings plans, because savings plans don't cover the same resources as RIs. For example, RDS, DynamoDB, Elasticache, etc., are not covered by savings plans. So you may need to have a portfolio mixed of RIs and savings plans. And as part of our service, we're helping customers to understand what is the best options in terms of three-year commits, 1 year commit. Certainly for savings plans, do you buy it centrally, or for chargeback purposes, would you be buying them at the linked account level? So we can help with all of that as part of the Densify service. Now, what covering off here is some information relating to that automating resource optimization and the challenges that enterprises are having. So what you'll be finding across your infrastructure at the moment, typically you'll be using different infrastructure as code technologies, Terraform, CloudFormation, etc. And what we're finding more and more is that customers are hard coding these entries. So in this snippet here of a Terraform template, we've got a hard coded entry for the instance type. So what this means is every time this template is run or applied, then it's the resource that's going to be stood up is an M4 large. So it's hard coded. And where do these hard coded entries come from? They come from educated guesses. They come from, well, this is the way we've always done it. But we know that the same resource allocation is not the best fit for all workload types. So typically it's suboptimal. And what it does do is create a huge problem in scale, because the more times you run this Terraform, you're purchasing the wrong infrastructure type, you're purchasing as code. So what we're doing is replacing this purchasing as code with optimization as code. So we're changing that hard-coded entries to variables, so that the call out is to say, Densify, tell us what I should stand up for this workload type. And obviously, if there is no workload for this, because it's the first time this service has come into existence, then the default value will be set. And then once we've built up enough workload history and able to provide an analysis, then that recommendation can be automatically fed back into the process to ensure that you're optimizing as code as you go along. So we get the resources back under control from the start, and this is done through the accuracy of the analytics. And it's far more sophisticated than humans can do. It's something that the engineering team, the application owners don't even need to worry about. And it allows also you to take advantage of your service provider, introducing new services at any time, and Densify understanding that new service that's available and determining if it's a good fit for your workloads. So as part of the overall digital strategy, so HeleCloud and Densify realize this is an integrated and collaborative approach. We need to take into consideration all these different teams. Application owners, engineering teams, they want to make sure applications are healthy. IT finance want all this to be done at the right cost. And of course, leadership are setting strategic goals. They want the business to be agile and reliable, but it all has to be done within a certain budget. But to be successful, everyone needs to work together as part of a collaborative approach. So we need to make sure that the environment is reliable and applications are performing well. Application owners need to be included. They need to understand what is happening. So they need the visibility and control. And that allows them to be informed, allows them to trust the information that's coming out from the environment, the recommendations, and then to approve the actions. It's only once we get the approved actions, once we can actually make the changes in the environment, that we're seeing the benefit across the environment to make sure the resources are cost appropriate, and ultimately allows IT finance to therefore make the best purchasing decisions based upon an optimized environment. So ultimately, we find that bringing all of this together is the most successful approach. And then finally, as part of the process, what we're trying to help customers do is get from that manual resource control to an automated resource control situation. And we do that through a number of steps. So initially, it's to start with the visibility. So you need to understand what the optimization potential is. Where is your risk? Where is the opportunity to save costs? So by bringing Densify in and doing that analysis, you can very quickly get your optimization potential. We can pass that information out to the key stakeholders so they can start to visualize and understand where the risk and opportunities are. And it allows the IT finance people to start to get an understanding of what they should be looking at in terms of purchasing strategies around RIs and savings plans. Then, of course, it's the actioning phase. We start to take some of those initial recommendations and start to apply them manually. We start to integrate with the change management tool set that the customer already has. And those progressive stakeholders, the ones that are more keen to take advantage of this new technology, this new capability, will start to apply their changes more readily. And then ultimately what we're driving to is the automation phase. So we're looking to get to that closed loop action automation. The recommendations are derived. The changes are approved in the organization. Action is taken. So this is integrating with a customer's CI/CD, CO, continuous optimization processes, so that we're just a plug into the environment to make it as effective as possible. So we're driving from that manual resource management current mode of operation to an automated resource capability for the environments. And typically the way we start all this off is with a POV, and that allows us to very quickly implement Densify so that you can get that optimization potential in a very quick period of time. So hopefully people have found that useful. Carlos, I'm going to hand back over to you.
Thank you, Roger. That was very useful. So what I'm going to do is I'm going to move on from the technology theme now to the financial theme and look at the areas that you need to consider. So we recommend this to be a monthly process, which starts with analyzing your spend. You can do this by using spreadsheets and databases to analyze your bill, or you can use a tool such as AWS Cost Explorer that you see here. And here is my personal bill for the last 6 months. You can see that most of my cost is in compute, primarily EC2, but in May, I had a large spike in my bill due to the use of AWS workspaces. What we find is that in most typical workloads, compute is the biggest spend, and it's important to understand your largest costs because this drives where you should be focusing your cost optimization efforts. And it shows why Densify is so useful because it concentrates on driving down those compute costs for you. Using Cost Explorer, you can look at your bill in a number of different ways, but, and this is key, you can only report on the data that AWS holds. In my case, I know why I had a spike in workspaces spend, but if this was your corporate bill, how would you track that down? And this is why tagging is so important, as you can then attribute the costs to projects, business units, and in any other way that you might want. Part of the analysis of your bill is to ensure that you're using the most cost-effective purchase options for your workloads. For instance, reserved and spot instances and savings plans, as Roger's mentioned. And on a regular basis, you should also check to see if there are any AWS incentives available to you through partners. So these typically fall into 3 categories: proof of concept, modernization, and migration. AWS will give you proof of concept credits if you want to try out a new service or technology in a well-controlled and defined way. For example, if you want to try out a blockchain database using AWS Quantum Ledger. The second funding channel is workload modernization. This might, for example, be moving from SQL Server on EC2 instance to Amazon Aurora. But modernization means that you are putting in effort to making your workloads cloud native, and applies even if you're already running your workload on AWS. By far the largest source of funding from AWS is associated with migrating complete workloads. Funding here is designed to help offset some of the costs associated with the migration. Although Cost Explorer is useful, Densify can provide you with more nuanced views of your spend by using its outliers feature shown here. This can spot anomalies both above and below certain thresholds using a moving average, alerting you to when your spending isn't what you'd expect. In this case, you can see a spike which happened on a Friday when the development team did a full volume test prior to a release. This is one of the great things about cloud, is that you can run a full production sized environment for testing and then hopefully spin it down when you no longer need it. Obviously, if the team had left the environment running, you would see the damage it would have done to our cost. But really, this session isn't about testing, so let's move on. I mentioned previously that that AWS Cost Explorer works well, but isn't very useful unless you've tagged your resources. And indeed, Densify also relies somewhat on tags. And tagging falls into our third theme, governance. This is about adopting corporate-wide strategies for establishing goals, creating a culture of control, measuring and monitoring costs associated with cloud usage. I'm not going to give you a complete framework here for governance, but want to talk about 4 particular areas and focus on just one. Roger has just covered continuous optimization. Although using Densify can address this area for you, you have to govern and mandate its use, as well as setting up a process for reviewing the recommendations the tool produces, evaluating those recommendations and implementing them. And because we've started on the right-hand side at the end, I'm going to go backwards. So cost for the cloud should be considered upfront during your design process in test and development. And typically, if you were running on premises, you would have done this. But as soon as you move to the cloud, it seems that that kind of cost control doesn't matter anymore, but that's not true. During the design stage, there should be a cost control exercise which looks to ensure that the most cost-effective strategies and services are being adopted for the workload being designed. Doing cost optimization after a workload is in production and deployed is more expensive than ensuring cost control is built in. Other areas in test and development to look for are idling development, test and UAT, and training workloads, which are often left on when not being used. At HeleCloud, all of the AWS team, including myself, have a sandbox where we test out new features and services, and at the end of the week, the resources are automatically deleted from those accounts. Although we do have a way around this, which I'll talk about when we look at tagging. Another good governance practice is to establish budgets in cost control, and AWS lets you create budgets right inside your account. What a budget does is it compares your spend against your targeted spend against your actual spend, and then you can create alerts based on those budgets to notify you when you're exceeding your forecasted you're exceeding your actual spend or your forecasted budget. You can also set up multiple budgets to track not only your costs, but also usage. But the thing you've got to remember with this is that budget information is not updated continuously, and the information is typically 8 to 12 hours old. So the final thing I want to focus on is the one on the left, which is tagging, and the impact that this has on cost control. Now, tags have a wide range of uses, but here we're talking about use of tags for cost control specifically. And whatever your use of tags, you'll want to take a considered view towards it, which means that you should define a tagging policy that embodies the best practices that we're talking about here, but also consider such things as naming conventions for your tags. This is doubly important because tags aren't hierarchical, and the tag universe is effectively flat. And in this example, you can see that I have 2 tags that we use for cost control, a line of business and a cost center that I've highlighted here. In the names, you can see we've used a 2-letter prefix for our organization, HeleCloud, and this is useful for a number of reasons. The first is that if you use any third-party tools in your workloads or services, these can create tags, and you don't want to be clashing with those. And secondly, if your organization acquires or merges with another organization that also uses AWS workloads, you'll more easily be able to bring your tagging systems together. And we know this, having acquired 2 companies in the past year. After you have your policy, you can start to tag your resources. Make sure that you tag everything that gets created. In fact, for some of the managed service customers that we have automated procedures in place that will destroy any resources created without tags. Having said that, we don't want to overdo it and have 40 different tags for every resource, so each tag should be justifying itself and its use. When you apply tags, apply them consistently. If you intend to use tags for specific use cases, you will need to rely on the consistent use of tags and tag values. If a significant portion of your AWS resources are missing tags that are used for cost allocation, your cost analysis and reporting process will be more complicated and time-consuming and less accurate. Likewise, if resources are missing a tag that identifies the presence of sensitive data, for instance, you may have to assume that all such resources contain sensitive data as a precautionary measure. When you begin tagging, start with a smaller set of tags that you know you'll need rather than specifying an overabundance of tags that you think you might need in the future. You may already have an authoritative, I can't say that word, authoritative source of tagging information in a corporate CMDB. And if you do, then consider integrating that into your resource creation so you can pick up tagging information from there. And finally, and this is important, when we talk about cost allocation, it's important to realize that tags are not retrospective. So as a result, when you introduce a new cost allocation tag, it takes effect starting from that point in time. The new tag will not apply to past cost allocation reports. Okay, so this has been a pretty quick look at tag. We'll try and take a more detailed look at tagging in a future event that we do. It's worthwhile, just before we round off, to look at two case studies from HeleCloud's managed services team. Our managed service team runs an optional cost control and management service for our clients whose workloads we manage. In both examples that I show here, the clients opted for the service after running for some time. And as you can see here in this first example, this customer's AWS spend was on an upward trajectory when they opted for the service. When the customer opts for a cost control and management service, our onboarding process includes an optimization exercise, which is why you generally see a good fall in the spend in the first month. However, some cost optimization techniques may need a lot of time to put into effect. For example, the cost optimization may need some re-platforming to a more cost-effective platform, such as moving a database off EC2 onto RDS. Hence, the AWS spend will typically continue to fall over time as the optimizations are implemented. And in this case, you can see that at the end of the year, the customer was spending 25% less monthly than before the optimization began. The second example here shows a similar pattern. I'm sorry I can't tell you the name of these two customers, but cost and expenditure information is considered sensitive for both of them. But in this case, you can see a significant drop in August. This is when we implemented business use hours of staging and test environments rather than having them on all the time, and hence the bigger drop there. So if you take away only one thing from this webinar, it should be that cost optimization has to be a holistic topic that shouldn't be seen as a point-in-time exercise, but as a way of working and controlling your workloads over the long term to achieve the best value from your AWS spend. Together, HeleCloud and Densify are uniquely positioned to help you analyze and reduce your AWS spend wherever you are on your journey. So we'd like to offer you a 30-minute discovery session to discuss your particular use case and see how you can help, how we can help you to reduce your AWS bill. So please feel free to contact us for your personal session.